Good morning, children. Last class, we have discussed about irrational numbers. What are irrationals? The numbers which cannot be written in the form P by Q are called irrational numbers. Then we studied how can we represent some irrational numbers on a number line, especially root 2, root 3 and root 5. Isn't it? And root 2 and root 3 actually we did in the last class, and root 5 was given as homework to you. And among you, only a few students did the how to draw this root 5. Isn't it? Remaining students hasn't completed it. So, let me explain once again, then we can move to our next topic. Isn't it? So, how to draw root 2? I told you already, we are all forming Pythagoras right triangles and we are applying Pythagoras theorem to get the values of root 2, root 3 and root 5. Also, to represent them on a number line. So for case of root 2, let me start with here I am considering only one side. Last class I have taken both sides to you. So let me start with 0 and I have taken only 1 centimeter distance in your scale. 1 centimeter only. Then altitude. Altitude means simply not a line. It is 90 degree line. Makes an angle 90 degree. Then we have a point B. Then by joining O to B, we can see that we will have the length root 2. We will have the length root 2. Then after, as I told you, 1 centimeter altitude needed. Then we have OB whose length is root 2. But root 2 length we got it now. So how to represent them? Either you do take your compass and keep the distance as radius. Keep your center here. Center of the compass here. Take this much length as radius, draw a line like this. Then you can see that this point represents root 2, positive root 2. And if you complete the arc to this side, you will get negative root 2. Isn't it? Next, let us move to root 3. In order to obtain root 3, we need to get root 2 first. In order to obtain root 3, we need to get root 2 first, because root 2 is considered to be the base of root 3. That's why first we have to get the value same as previous one, 1 centimeter distance, again 1 centimeter altitude, we have root 2. After getting root 2, keep your protractor on this line OB and you draw again an altitude 1 centimeter length. Again your altitude as 1 centimeter. You have a point C, join OC, you will have the length root 3. Again same as previous one, take your compass with this distance as radius, keep the center at O and you complete an arc like this. And this point is considered to be your root 3 on the number line. But when you want to draw root 5, there is a small and direct method for you. That is, instead of taking 1 centimeter as base, here I am going to take 2 centimeter as base. 2 centimeter as base and same altitude 1 centimeter. Same altitude 1 centimeter, which gives OB whose length is root 5. Which gives root 5. Then using compass and pencil, keep the center at O. OB as radius, you can draw an arc like this. And this point is considered to be root 5. Similarly, how can we draw root 17 on number line? What we do? Root 17. That's the thing I told you already actually. 17 can be written as 16 plus 1. 16 plus 1. Take the square roots of these two. One as base, one as altitude. So the base square root of 16 is 4. So what you have to take? 4 units you have to take. How much distance you have to take? 4 centimeter distance you have to take it as your base. And root of 1 is 1 itself. So this is your 1 centimeter. If you join this OB will be of length root 17. Is it clear? Similarly, suppose if you take the value of root of 50, already you know how to write 50. 50 can be written as 49 plus 1. 49 plus 1. See, take square root of these two. First square root of 49 will give you how much distance? 7 is the answer. So take 7 centimeter distance as your base. This is not proper distance. You have to take your scale and measure it. Okay. This is not 7 centimeter actually. Teacher has taken a rough only. So go through your scale and take 7 centimeter as your base. And same root 1. Root 1 is 1 itself. So this is 1 centimeter. And if you join, you will have an OB whose length is root 50. Is it clear or not? These are the main representation. It can be expected for the examination also. Okay, this is very important. How to represent, especially the 3 you have to study root 2, root 3 and root 5. I think it's clear to you. Is it clear? Okay. So let us continue. After representation of root 2, root 3 and root 5 on number line, next we are moving to our exercise question 1.2. Exercise 1.2. In this 1.2, actually this is not given for your examination point of view, but this is the basic thing you have to get the idea. You have to understand. Okay, you needn't want to by heart, you have to get the idea only. So let me go through question number 1. Question number 1 told you that every irrational number is a real number. They told you to write whether it is true or false with reasons. So what is it, true or false? Every irrational number is a real number. Is it true or false? It's true. Why? Because it is true statement. Why? Because real number system is the largest number system, which includes natural numbers, whole numbers, integers, rationals, irrationals, everything inside real number system. Isn't it? The whole number system consists of real numbers. So, real number system consists of numbers of all the types that you have studied. Natural numbers, whole numbers, integers, then rationals, irrationals, etc. All these systems includes in a group of real numbers. So, the given statement is always true. So, what you have to write the reason as? Real number system contains all the contains rationals and irrationals. Rationals and irrationals. Real number system contains rational and irrational numbers. So, teacher, instead of writing numbers, here I am writing rationals and irrationals. Is it clear? Because real number system is the big one. So, every irrational number is considered to be a real number. Next, let us go through question number 2. Every point on the number line is of the form root m, where m is a natural number. Where m is a...
എന്താ കാട്ടല്ലേ ക്ലിയർ ആവണത്തിന് ക്യാൻസൽ ആവാൻ പറ്റണം തുടങ്ങി.
Every point on the number line is of the form root m, where m is a natural number. This is false statement. Why? See, when you consider any point on the number line, that should be of the form root m they told. So, when you consider a number line, we can represent, see, 0 somewhat middle. On the left side, we can put root 1, root 2, root 4, root 1.1, root of 1.3, etc. Any number you like. But see, every number on the right side, there exists its own identity with a negative sign on this side. Isn't it? So, suppose if you consider a number of the form, root 5 is possible, we studied now. Suppose for example, root 5 can be represented on the number line we studied. Suppose when you take root of minus 5, suppose there is a possibility root of minus 5, what will happen? Can you represent? No. Why? Because root of negative 5 is considered, or we can write it as 5 small I. 5i. Root of a negative number can be written as 5i. This is called complex number. This is called complex number that you will study more in higher classes. Isn't it? So now what you have to do? We have to consider